Hello, my name is Dev Modi. My ID number is 21dce061. My topic is 8086 architecture. Now it is basically divided into two types, EU and BIU. EU means execution unit and BIU means bus interface unit. Execution unit executes the instructions that have already been fetched by BIU, and BIU fetches instructions, reads data from memory and IO parts, writes data to memory and IO parts. Now this is the architecture of 8086. Here there are segment registers. In segment register there is code segment, data segment, stack segment, and extra segment. First, we will going to explain code segment register. Code segment register is of 16-bit. Code segment contains the base or start of the current code segment. IP contains the distance or offset from this address to the next instruction byte to be fetched. Now we are going to see data segment register. Data segment register is also of 16-bit. It points to the current data segment. Operands for most instructors are fetched from this segment. Stack segment register. It is also of 16-bit. It points to the current stack. The 20-bit physical stack address is calculated from the stack segment and the stack pointer from stack instructions such as push and pop. If we talk about extra segment register, it is of 16-bit. It points to the extra segment in which data in excess of 64 KB pointed to the DS is stored. Now, if you talk about pointers, there are two types of pointers. Instruction pointer. Now, if you talk about instruction pointer, it is of 16-bit. So this register contains the 16-bit offset address pointing to the next instruction code within the 64 KB of the code segment area. Instruction queue. It works like queue first in first out. This is done in order to speed up by the execution by overlapping instruction fetch with execution. This mechanism is known as pipelining. Execution unit. Execution unit decodes and executes the instructions. A decoder in the EU control system translates instructions. Now, there are four common registers: AX, BX, CX, and DX. AX means accumulated register, consists of two 8-bit registers, that is AL and AH. AL means lower and AH means higher. Multiplication and division instructions also use the AL and AX. BX register, base register, consists of 2-bit BL and BH. BL means low bit and BH means high bit. BL in the this is only general purpose register whose content can be used for addressing in the 8086 memory. Counter register. Counter register is also of two 8-bit registers, CL and CH. CL is for lower one and CH is for higher one. Instructions such as shift, rotate, and loop use the contents of CX as a counter. DX register, data register, consists of two 8-bit registers, DL and DH, used to hold the high 16-bit result in 16 cross 16 multiplication or the high 16-bit dividend before a 32-16 division. Now there are stack pointer and base pointer. The stack pointer is used as an offset from the current stack during execution of instructions that involve the stack segment. Base pointer contains an offset address in the current stack segment, which is used by instruction utilizing the based addressing mode. Source index and destination index. Source index is used for source purpose and destination is used for destination purpose. Now, if we talk about flag register, there are 50, the flag register is of 16 bit, out of which 9 bits are used. The first bit is used for carry flag. Carry flag, this flag is set when there is a carry out of MSB in case of addition or a borrow in case of subtraction. Parity flag, this flag is set to 1 if the lower byte of the result contains even number of ones, for odd number of ones set to 0. Now auxiliary carry flag. This is set if there is a carry from the lowest nibble bit 3 during addition or borrow for the lowest nibble bit 3 during subtraction. Zero flag. Zero flag. This flag is set if the result computations or comparison performed by an instruction is 0. Sign flag. The sign flag is used when the result of any computation is negative. Trap flag. Trap flag is used when the processor enters the single step execution mode by generating internal interrupts after the execution of each instruction. Overflow flag. Overflow flag. This flag is set when overflow occurs. Direction flag. This is used by string manipulation. If the flag is set 0, that means that the string will goes from lowest to highest address. Interrupt flag. Interrupt flag causes the 8086 to recognize external mask interrupts. Clearing IF disables these interrupts. Thank you.